and you don't have to come in, and life's good, right? Let me see if did that work? Yeah, we're good. We're good to go. Okay, so um, anyway, so this is our problem set. And I added two problems, and I know I put them on the website. So this is I'm pulling them off from my hard drive, but they're also on the website. All right. So there's two things that can cause you to not have to go to third degree polynomial that you got to dissect like we ran into the other day. And I apologize. I ran right into it like a freight train. But I said we won't have to do anything like that. If the only thing we'd have to do would be to set it up, if we even had to do that. And then I got to looking, and these are two problems that do not require a a third degree polynomial. And basically, if you keep away from L's, R's, and C's, you're okay. Okay, if you have a two equations, two unknowns, and you've got L's, R's, and C's, all three, then you start getting into those third order equations. But if you have just L's and R's, you don't. And if you have a situation like this one is what? You were in position, it doesn't really say this, but you were in position A for a long time, and then you went to position B. What did that do? Put a bunch of initial conditions in, didn't it? It loaded you up with initial conditions, but you have to then add voltage supplies here and here. So with that in mind, you have two choices. You can either do superposition, or you can do what? Loop equations. So basically, loop equations fit this situation and this situation both. And these are the two examples that they had in the Van Valkenburg book. And these are the two examples that I just took out from Van Valkenburg and said, okay, we're going to do these. These will be our last two questions that we have, different type, but yet you can use loop equations. And I want you to be able to use loop equations because this is the kind of stuff that you would potentially be asked on if you want to get a master's degree in electrical engineering, you got to be able to solve these. All right. And if you want to get your PE, you better be able to solve these. At least know how to solve them. You might not, they may not toss you exactly one like this, but you better know how to solve a loop equation with Laplace. And that's the two that you can solve, and that other one let you down a rabbit hole with the L's, R's, and C's, and you got a third degree polynomial. And those are, you can solve those, but they're painful and very, 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 very hard to solve. And we usually don't expect you to be able to solve a third order polynomial and factor it. Second order, yeah, minus b, plus or minus squared b squared minus 4ac, quadratic equation. Rip it off every time and you're done. But this one you can solve. These two you can solve, okay? So let's solve. All right, so how would you do number 54? All right, let's do number 54. All right, so how would you do that one? So it would be, all right, so you've got 30 U of t, and you've got 10. And by the way, this is exactly out of, except for the 30, I think they had 100, but this is exactly out of Van Valkenburg. This is 10, this is 1, this is 10, this is 10 ohms, this is 1 Henry. Here you go, and this is 10 ohms. So this is kind of a, whatever, loop equation, I1, I2, okay? So it is minus 30 over S plus 10 I1 plus I shouldn't say that. I should say what? Ten plus S I1 plus I1 minus I2, parenthesis, times 10 equals 0. Does that make sense? It's exactly how it's done. Okay, the second equation. I2, this is I2, Ted. I2 minus I1, parenthesis, times 10 plus I2 times S plus 10 equals 0. Sort and sift. You like my terms, sort and sift, kind of rings, but it's the truth. What you're doing here is you're sorting and sifting. So you've got I1, now you're in standard form. Okay, now you go to standard form. So it's I1 times what? Check these off. It's 20, or it's S plus 20. And you check them off. Check off, check off, check off, right? Plus I2 times what? Minus 10. Everybody see that? Check it off. Equals 30 over S. Write the second equation. I1 times minus 10. And by the way, the cross diagonals always have to be the same in these equations. The off diagonals always have to match. Minus 10, minus 10. If you don't have that, you made a mistake, okay? Minus 10 I1 plus I2, what? S plus 20, right? S plus 20 equals 0. Now you go to war, okay? So what is I1? Well, you take this 30 over S and 0, and you take the minus 10 and the S plus 20, and that's your numerator. That's your determinant. This is called a determinant in the numerator, okay? And it is 30 over S times S plus 20 minus 0. And then the denominator, it's what? S plus 20 minus 10 minus 10 S plus 20. Okay? So your I1 is equal to 30 over S times S plus 20 over S plus 20 quantity squared minus a plus 100, so it is minus 100. This times this is 100. Okay, now there it is. Now what do you do with it? Now the mess starts. Okay, now the real work starts. So you have to get this into something that you can then do separation of variables with, and that's the hard part. And this is what makes you an electrical engineer, by the way. Being able to do stuff like this. If you cannot manipulate this kind of stuff, it's kind of like, well, I shouldn't say that, but this is the kind of stuff that separates you from other engineering types. How's that? Your mechanical engineering brothers typically don't do this kind of stuff. Okay, so now you're down to the mess. So it's 30 times S plus 20 all over S all over S squared plus 40S plus 2 plus 400 minus 100. So we have 30 times S plus 20 all over S times S squared plus 40S plus 300. This is not nice. those numbers are getting kind of big, and we don't like big numbers, but we've got them. So now let's just see. I should not have put 10 in there. How's that? I should have put a small number like 2 or 3, and it would have been a lot easier. I did not know that when I started this up, but anyway, that's what I should have done. Anyway, so how do you finish this off? Well, now you can do separation of variables. I1 is equal to what? A over S plus, now this is B squared. Okay, so it's minus B plus or minus square root of B squared minus 4 times 1 times C all over 2A. What is that? You gotta use your calculator out, right? It's calculator time. So this is a mess, and I didn't realize it until right now, but we should have kept those numbers small, like 2 and 3, and it would have been a lot easier. But this throws it into this throws it into minus numbers, right? Because 4 times 300 is 1200. It's going to be bigger than 40 squared. So it's 4 times 300 minus 40 squared, okay, is equal to minus 400. It's not so bad. So minus 400 is minus 20. So it's minus 40 plus or minus 20j all over 2, or it's equal to what? It's k over s plus 20 plus 10j plus k star over s plus 20 minus 10j. Everybody see that? Now you go to war. Now you're final. Now you're down to the easy part. All right? So what's the easy part? Well, now I have to set this up equal to what? Equal to 30 times s plus 20. And I solve. Let s equal 0. And that would give me what? That's a times s squared plus 40s plus 300 plus the rest of it goes away is equal to 30 times s plus 20. And the s's go away. And so a times 300 is equal to 60. What's 60 over 300 is a is equal to 0.4. What's 60 over 300? No, 0.2. 0.2. What is K? K is equal to, okay, so you let, right, let S equal what? Minus 20 minus 10j. We cross multiply and we get 30 times s plus 20 is equal to k times 20j. Minus 20j. Okay? So let s minus 20 minus 20, so it's 30 times minus 20 plus 20, so it's times minus 10j is equal to k times minus 20j, or k is equal to, the j's cancel out. Very good. This was kind of an interesting one. K is equal to 15. Is that right? I think so. Yeah, it is. Yeah, it's a half. So now our answer is what? I1 of t is equal to what? And I'm not going to do I2. Basically, we're just going to, it's 0.2 plus 30, 2 times k, e to the minus 20t cosine of 10t plus 0 degrees. Plus 0 degrees. That one fell out pretty easy. I think that's how it's done. Pretty straightforward. Now, the other one is not any worse, I don't think. I hope it's about the same, but this is how you do these. All right, so let's do a new one. New. Answer is yes. So it is 8:30. They start the meeting. So I need to be there at 8:45 or thereabouts. So anyway, so let's do this one. This is number 55. That'll be our last one we do today. But what happens with this one? This, I didn't state it, but at t equals 0, it switches from A to B. It's been an A for a long time, and then it goes to B. So what's the deal here with this? All right, so what's the big deal? This is a pre-charged situation, isn't it? So when we start this thing, we've got 10, we've got 1, we've got 1, and we've got a capacitor here sitting here with a voltage on it. Another capacitor sitting here with a voltage on it. We've got 5 over here. Okay, so we've got 1, 5, 1, and 2. All right, so what would be the voltage sitting on this one? It's 30. What's the voltage on this one? It's also 30. So if you do that, what do you have to do? You have to add a supply, don't you? You have to physically redraw this, and you say, now, what are the conditions that I start here with? So I start with a 1 over here, and I start here with a capacitor of what? 1 over 2s, or 0.5 over s. And down here I have a what? Plus to minus 30 over s supply. And over here I have another over s, and I have a plus to minus 30 over s supply. And then I have a 5 ohm resistor over here. So now what do we have to do now? Let's do this in red because it gets confusing if we don't change colors. Okay, so now we do this in red. I1. This is I2. All right, now let's go back to black and write our colors again. Now let's write our equations, okay? I1 times 1, which is I'm going around like this, plus I1 minus I2 times what? 0.5 over S plus 30 over S equals 0. That's the I1 loop. What's the I2 loop? Minus 30 over S plus I2 minus I1 times 0.5 over S plus I2 times 1 over S plus 5 plus 30 equals 0, 30 over S. Now note, in this situation, these cancel each other out. They go away. But in this one, they don't. Okay? So you say, well, you live and you die by these things, but this is exactly how you do this. So now I've got the sorting and sifting going on, all right? So it is I1 times what? 1 plus 0.5 over S plus I2 times minus 0.5 over S equals minus 30 over S. Second equation, I1 times minus 0.5 over S plus I2 times, now you got a mess. You got 0.5 plus, so it's 1.5 over S. That's that one and that one, plus 5 is equal to 0. You got that one, you got that one, and that one. So now you're done, okay? So what is I1, what is I2? Let's just do I1 and we'll be done, okay? What is I1? Minus 30 over S and 0. Minus 0.5 over S. 1.5 over S plus 5. All over 1 plus 0.5 over S minus 0.5 over S minus 0.5 over S, 1.5 over S plus 5. Ugh. Now you got to multiply all this stuff out, and then you got to digest it. Okay, so that's what you got to do. This gets to be burly. This gets to be a mess, but I think it'll work. But that's how it's done. Okay? All right, so I'm going to give you something to do over that break that I'm giving you, but it's going to be a couple or three of these problems. But you should be able to work this. It's just a lot of parts and pieces. Minus 30 over S times 1.5 over S plus 5 over 1 plus 0.5 over S times 1.5 over S plus 5 plus, minus 10. Minus 0.5 over S quantity squared. Now this gets to be interesting. All right. Everybody agree? It's interesting. But doable. All right. Not necessarily fun, but it's doable. Right. So minus 30 over S times 1.5 is minus 45 over S squared minus 150 over S all over 0.5 over S plus 0.5 times 1.5 squared plus 5 plus 5 times 0.5 or 2.5 over S. All right, so now you've got to get down to the, okay, so this is 1 times 1.5 over S. 1 times 5 is 5. 1.5 times 1.5 over S squared. And then that's then minus 0.25 over S squared. All right, so let's clear the deck and get all these down to what they've got to be, and we'll figure it out. So this is equal to what? This I1 is equal to this. So now I1 is equal to minus 150 S minus 45 over S squared. All over, it's going to be something over S squared. So it's 1.5 S plus 2.5 S, or 4S over S squared, plus 0.5 times 1.5 is 0.75, minus 0.25 or 0.5, so it's plus 0.5 over S squared, plus 5S squared all over S squared. The S squareds go away. So now we have minus 150 S minus 45 over 5S squared plus 4S plus 5.5. Yeah. Okay. Is that right? Does that look right? Because if we don't get this right, it ain't gonna, nothing else is gonna work. Yeah, it is. It is right. Okay, plus 0.5. Now, what we've got to do now is we've got to do what? Divide 3 by 5. So it is what? 30 S minus 9, minus 30S minus 9 over S squared plus 0.8S plus 0.1. So what do you do with that? Put the denominator in the quadratic equation and get your two parts, okay? And that's it. So now we go up here someplace and we can do the rest of it. Let's go back over here. Did I mess up anywhere? Did anybody say anything? You don't see anything I did? Okay. Hopefully I'm okay. So let's just go. So minus b minus 0.8 plus or minus square root of b squared, 0.8 squared, minus 4 times a times 0.1 all over 2a or 2. 0.8 squared is 0.64. 0.64 minus 0.4 is equal to what? 6 over 25 square, that's 0.24. Square root of 0.24 is equal to 0.489 minus 0.8 plus or minus 0.489 all over 2. I'll do that again. 0.8 squared minus 4 times 0.1 is equal to 6 over 25. 625 square root of 6.6. Yeah. 0.489. So it's 0.8 plus or minus 0.489, and these are real roots. These are not imaginary roots. So now all you got to do is you got to say it's equal to what? A over 0.8 plus 0.8 plus 0.489 equals, okay, 0.8 parenthesis Ted, parenthesis 0.8 plus 0.489 into parenthesis divided by 2 is equal to 0.644. So that one is the addition. The other is parenthesis 0.8 minus 0.489 parenthesis divided by 2 is equal to 0.155. You're done. So here you plug in 0.644, S equals minus 0.644. So here you plug in 0.644 and 0.155 and you're done, okay? I gotta go. Any questions about how this is done? Piece of cake? Pretty much. You see how you play this game? Not a biggie. But it is doable. These are very doable. Okay, so I've got to go to that meeting. I'm sorry, but